Alright everybody, what's up? We got us a nice little problem to work today. We've got the limit as x goes to 0 of square root of 1 minus cosine 2x over the square root of 2 times x. Now let's go ahead and start working this. So this is going to be the limit as x goes to 0. And yes, there might be some other ways to work it, but let's work it this way. So this is going to be the square root of 1 minus 2 sine squared x over square root of 2x. Now where did that come from? Well, I've got my 1 minus, and then cosine 2x I'm replacing with 1 minus 2 sine squared x. That's a double angle identity for cosine. Okay, remember the double angle identities from trig. All right, and then simplifying, we get the limit as x goes to 0 of square root of 2 sine squared x over square root of 2x. See, I've got 1 minus 1 is 0, and then distribute that negative makes it a positive. And so now we get the limit as x goes to 0, square root of 2, absolute value of sine x over square root of 2x. All right, so why absolute value? Well, remember, whenever you're taking the absolute value of something, whenever you're taking the square root of something, you have to get a positive answer. Well, there are times when sign can be negative. So we need to put it in absolute value so we ensure that we get a positive answer. And so now this is going to give us the limit as x goes to 0 of absolute value sine x over x. The square root of 2's cancel. Now to find this limit here, you can see if we plug x in, we get 0 over 0. Okay. So to do this limit, we can show that the limit from the left and the limit from the right, they have to equal the same thing in order for the limit to exist. So let's do the limit as x goes to 0 from the right. All right, and you can see when we plug in the 0, we get 0 over 0. So we can actually write this as the limit as x goes to 0 from the right of sine x over x. Okay, because we're coming into 0 from the right and we're plugging in positive numbers. We're in the first quadrant. We're coming into 0. Okay, remember the first quadrant, we got 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. And we're coming into 0 from the right-hand side, so that's positive numbers. We're in the first quadrant. We know sine is positive there, and so the absolute value of sine x is just sine x. It's positive. And so with this, the 0 over 0, we can apply L'Hopital's rule. So that's the limit as x goes to 0 from the right of cosine x over 1, which is cosine of 0, which equals 1. All right, so that's the limit from the right. Now let's do the limit from the left. All right, so what does this equal? Well, this is equal to the limit as x goes to 0 from the left of negative sine x over x. Now, where did that come from? Well, if you remember, the absolute value of x is equal to x if x is greater than or equal to 0, and negative x if x is less than 0. All right, so we can see that this right here, this sign x inside the absolute value, we're coming into 0 from the left. So that's down here in the fourth quadrant. So we're coming to 0 from the left, and sign would be negative. Okay, this would be negative. So since this inside the absolute value is less than 0, it's negative sine x. All right. And then once again, when we plug the 0 in, we get 0 over 0. We can apply L'Hopital's rule. So that's going to be negative cosine x over 1. And so that's going to be negative cosine of 0, which equals negative 1. And so we have the limit as x goes to 0 from the right of absolute value sine x over x is equal to 1, which does not equal the negative 1 here, which is the limit as x goes to 0 from the left of absolute value sine x over x. And since those limits are not equal, then we can say the limit as x goes to 0 of square root of 1 minus cosine 2x over square root of 2x does not exist. All right, so hopefully all that made sense to you. Hope you enjoyed the video. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see y'all later.